All right, Chemistry 1012, let's take a look at this question from Chapter 12. It's question 12.54. It says, write an equation showing the dehydration of these alcohols. So the first alcohol that we're starting with in A, you can see the parent has a total of 4 carbons. So we have butan, and then we have the alcohol on the second carbon, 1, 2, 3, 4. So this would be 2-butanol. So I'm going to scribble that name down here. So this is 2-butan. So I'll just move that down here, 2-butanol. So we're going to take 2-butanol and then we're going to perform a dehydration on this alcohol. So what do we need for that? We need to heat that up. Okay, we can write the delta symbol, or we can just say, acid catalyst and heat. Okay, and what's that going to do? When we heat it up, it's going to drive water from the molecule. So I'm going to write down here, subtract H2O, because we're going to be losing water. Now, where is that water going to come from? Well, what do we need to make water? I know you all know the Lewis structure of water has 2 hydrogens attached to an oxygen, which has 2 bonds and 2 lone pairs. And so we have OH, and we're going to get part of our water molecule from that. So we're going to get one part of our water molecule from that, but we also need another hydrogen atom. So where does that hydrogen atom come from? Well, it turns out that that hydrogen atom can come from the neighboring carbon from the carbon that is attached to the hydroxyl. So if you're unclear about that, so this carbon that I'm highlighting in green right now, that's the one that's attached to the hydroxyl. So it means that the hydrogen has to come from one of the neighboring carbons. So it can either come from this carbon in red, or it can come from this carbon in blue. So which one is going to give us the hydrogen to produce the alkene, our final product? Well, if I remove a proton from the carbon that I have highlighted in blue, what I would end up with in that case would be something that looks like this. I'll have my CH3, then my CH, and then my CH, and then I'll have a double bond here, and then I'll have my CH3. Now this compound is called 2-butene, all right? Now, if I was to take a hydrogen off of the carbon that I have highlighted in red, then I would have CH2, double bond to the CH, and then I have my CH2, CH3. And this compound is 1-butene, and you should know the nomenclature of alkenes that were covered earlier on. So which one of these is going to be the major product in this case? Well, this is going to follow Zaitsev's rule. So you need to be fully aware of Zaitsev's rule, which states that the major product is going to be the most stable alkene. So the question is, which one of these 2 alkenes is the most stable? And the answer is the 2-butene is going to be the most stable alkene. Now, why is that? Because we look at the 2 carbons that are involved in the double bond. So I'll highlight them both in yellow. And then we count the total number of carbons that they're attached to. And they are attached to a total of 2 carbons, 1 on each. So we call that a disubstituted alkene. Whereas in the 1-butene, if I highlight the 2 carbons involved in the double bond, how many carbons are they directly attached to? And the answer is only 1. And so the 2-butene is disubstituted, or a disubstituted alkene, whereas the 1-butene is a monosubstituted alkene. And so the 2-butene is going to be our major product in this case. So we're going to write major product here. Okay, now for B, the molecule that we're going to be starting out with is this one that you see down here at the bottom left of the screen. So I'm just going to move up a little bit here, and we're going to start by naming this molecule. And of course, we're going to start numbering where the oxygen is attached to the ring. And so that's going to be 1, 2, 3, 4, 5. So this is a cyclopentanol, and then we have a methyl group at carbon 2. So this is going to be 2-methyl cyclopentanol. So I'll scribble that down here. 2-methyl cyclopentanol. Okay, 2-methyl cyclopentanol. So what we're going to do is we're going to do a dehydration reaction. So we're going to treat this with heat. We can write the word heat out. And of course, we need an acid catalyst. I think the last time I listed the acid catalyst first, so I'll put it like that, heat. And of course, in the process, we're going to lose what small molecule? Well, I don't know about you, but when I get heated up, I lose plenty of water, right? So what's going to happen here is that we're going to lose the OH. That's going to make up one part of our water molecule, but we still need another hydrogen. So what do? We look at the neighboring carbons to the carbon that has the OH group attached to it. So if I highlight this carbon in yellow, This is the carbon that has the OH attached to it. Now it has two neighbors. I'm going to highlight this one in red, and I'm going to highlight this one in blue. This is for instructional purposes only, okay? So if I was to remove one of the hydrogens, and there are two on this carbon in red, okay, I can fill them in. I'm going to delete them. But if I was to remove one of those hydrogens, what would the alkene look like? Well, let's draw it. It would look like this. I'd have a double bond here, okay, and I would have my methyl group down here. All right, so how would we name this compound? Well, we have 1, 2, 3, so we would call this 3-methyl cyclohexene. All right. So if I was to remove a proton from the carbon that I have highlighted in blue, I would end up with my double bond being here and producing this cycloalkene. So how would we name that compound? Well, we're going to start with our number 1 here, number 2 like this. So this would be 1-methyl cyclopentene. So I'm going to put that down here, 1-methyl cyclopentene, which makes me realize I made a mistake in the previous one. So this should be cyclopentene. So methyl cyclo, where's my red pen? Cyclopentene. There we go, fix that. All right, so which one of these is going to be the major product? Well, I'm going to delete the numbers that I have on here just so we can see what's going on. And if I take a look at the two alkenes, so let's highlight the carbons of the double bond in yellow for the red one. Now, how many total carbons are attached to the carbons in the double bond? And the answer is 1, 2. Whereas in the second structure, in the blue one, in the 1-methyl cyclopentene, if I highlight these two carbons in yellow, how many carbons are they attached to overall? And the answer is 1, 2, 3. So the cycloalkene in blue is tri-substituted, whereas the one in red is di-substituted. And so, as we said before, the more substituted alkene is the one that we call the Zaitsev alkene. Get my black pen here. This is the Zaitsev alkene. So this is the Zaitsev product. And so we are going to say that this is our major product. The more substituted alkene is going to be the major product. Why? Because it's more stable. Now, if you're wondering, does the minor product, does that have a name? It does. We call that the Hoffman product. So the Hoffman product. And the same goes for the previous question as well. You would call this product here, you'd call that the Hoffman. I don't remember if our textbook really brings that up a whole lot or not. However, you do have to understand Zaitsev products, which again are major products. And there you go. So I hope you learned a little bit about dehydration of alkenes.